Okay, guys, so this is going to be using the slope-intercept form that I just showed you in order to actually create the slope-intercept form. So we may not know some things, but we can always figure some things out. So watch how we can figure these out. Okay, I'm going to step out of the way here so you can see what this says. So please write this down in your notebook. Notice that we have using 2 points to create slope-intercept form. The reason I'm saying that is because if you have 2 points, you can always draw a straight line. So if you can draw a straight line, that means that it's linear. If it's linear, that means it's got to have a starting point and it's got to have a slope. It's got to have a rate of change. It's increasing or decreasing. And so we're going to take a look at these 2 points right here. -1, -2 is one of the points. 3 and 4 is one of the points. Y equals mx plus b is the form we want to put it in so we can figure out anything. This slope-intercept form means if I pick something, if I pick a number, I should be able to figure out what the output is. So x is your input, y is your output. I'll be able to figure out for anything. Right now, we only know 2 solutions to this line, and the 2 solutions are -1, -2, and 3 and 4. So let's make this all make sense. So first, here are your 2 points. If I place them on a graph, and I just sketched a graph down here, this is going to be -1, -2. It's going to be somewhere right around in that area. If I do 3, 4, it's over 3, up 4, it's going to be somewhere up in there. If I connect those two using a straight line, now I'm not perfect, so I don't know if this is perfect because I just sketched it, but it seems to me like this graph is going to go somewhere through the y-intercept at 0, but we can't trust the graph. So I can't bring this 0 and just put it over here because I can't trust that. Okay, so don't worry, you can't just throw a b in there. We have to mathematically prove what that y-intercept is. So here's how we do that. Since we know 2 points, we can figure out this. You can figure out the slope. Here's how you do that. This will never change. This is the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Here's where you get those numbers. You get these numbers from the 2 points that you know. This is the first coordinate pair. So it is x sub 1 and y sub 1. This is the second coordinate pair. So this is x sub 2 and y sub 2. Remember, every coordinate pair is an x and a y, an x and a y. That's where we get these x and y's over here. So we're going to use these 2 points to put into our formula in order to figure out what this part of our slope-intercept form is. So y sub 2 is 4 minus y sub 1. Now this is weird because here's what we have. 4 minus a -2. Minus is part of the formula. It has to be kept there. But then we also have this -2 over here because that's what y sub 1 was. X sub 2 minus x sub 1 is 3 minus a -1 because we had a 3 and a -1. Now, if you aren't good with adding and subtracting integers, please watch the video under your resources part of the classroom. Go to your classwork, go to resources, go to adding and subtracting integers. Because in that little video, I show you how to do this, but I'll tell you very quickly. Anytime you see minus a negative, anytime you see minus a negative in math, it is the only time that integers get difficult because you have to remember this as part of the math language. Minus a negative means plus. So this is actually 4 plus 2, and this is 3 plus 1. I like to think of it as you have 2 negatives. Those 2 negatives come together to give you 1 positive. I just slide them together to give me the plus sign. So 4 plus 2 is 6, and 3 plus 1 is 4. Now, we can simplify that. So we will simplify, but we're still going to leave it as an improper fraction because fractions are your friends in algebra. So if I divide 6 and 4 both by 2, I get 3 over 2. So 3 over 2 is my slope. What does that mean? Here's what it means for us. Now we have this. We still don't know the y-intercept, but we figured out what the slope was. This is the rate of change. We do know x and y. Here's why we know x and y. Because when you look over here, they gave us 2 points that were on that line. Now, we can select any x or any y we want. So we're going to select this one. Now, there's a reason I'm selecting that one. You can select any one you want. I'm only selecting this one because they're both positive numbers, easier to work with, no big deal. So here's what we're going to do with those two positive numbers. X is 3. We're going to put it in there and multiply by 3. Y is 4. We're going to put it over here as 4. We can simplify this. 3 halves times 3 over 1 is 9 halves. So this is going to be 4 equals 9 halves plus b. So we're going back to these equations that we did. This side's now simplified. This side's now simplified. If I take 9 halves away from both sides, that means 4 minus 9 halves. Well, if you need a calculator to do 4 minus 9 halves, go right ahead. If you want to change 9 halves into a mixed number, it's 4 and 1/2, because 9 divided by 2 is 4 and 1/2. So if I take 4 1/2 away from both sides, I will be left with just a b over here. And over here, I will be left with 4 minus 4 1/2, which will leave you with negative 1/2. It'll be negative 1/2. Okay, so here's what that means. If I come back up here, I now know that the b is no longer going to be the b because we just figured out b equals negative 1/2. So I can get rid of this b and I can put minus 1/2 right there. Now remember I told you that I don't want to necessarily go off my sketch. Well, here's what we just proved. The negative 1/2 is where it's going to cross the y-axis. So my graph is off a little tiny bit. The 3 over 2 is positive, so my slope is increasing. It's going up from left to right. And if I start at this point and I rise 3, remember slope is rise over run. We talked about that in the linear equations video. If I rise 3, 1, 2, 3, and I run 2, I'm going to go up 3 and over 2. I'm going to end up back on the line. I'm going to go up 3 and over 2, and I'm going to end up back on the line. So every time you rise and you run, you're going to end up back on the line. The reason we created this in slope-intercept form is because what if I wanted to know what the answer is if I put the next point in, maybe will be a 5. Well, if I insert a 5 in here, then I could do 3 1/2 times, or 3 halves times 5, which is 15 halves, which is 7 1/2. And 7 1/2 minus 1/2 is 7. So my y would be 7. So this point should also go through the point 5, 7. Okay, so I can figure out anything. When you know the equation, when you know the linear equation, we can figure out anything that we want to. Okay, that is how you use 2 points to create a slope-intercept form. So we started off with nothing here. We knew 2 points. Anytime you know 2 points, you can create slope. Remember that. That's big. Anytime you got 2 points, you can create slope. Once you create the slope, you can just put any point in for x and y. Just replace them, and then you can figure out your y-intercept, and then you can rewrite this as your true slope-intercept form. Okay. If you have questions, I know it's a lot. If you've got questions on this, please ask me during class. Please pause the video, make sense of what you have to do whatever you've got to do. I'll help you. So always obviously text me, or email me, and I will get back to you with a video on how to help you solve these things. Slope-intercept form.